Hi everybody, we're going to be talking about notes from the 8th grade Common Core Lesson 2.5 Similar Figures. The first part of the notes is knowing the definition of similar figures. So please make sure you're writing down that similar figures are figures that have the same shape but not necessarily the same size. It'll either be a smaller version or an enlarged version of the original figure. In similar figures, there's two characteristics in order to classify figures as similar, and the first one is that corresponding side lengths are proportional, which means you're going to use proportions, and the corresponding angles are congruent. Remember that congruent means the exact same. So, similar figures, figures that are the same shape but not the same size, and they need to have corresponding side lengths that are proportional and corresponding angles that are congruent, the same. So we're going to go ahead and in example 1, identify if they are similar or not, and then in example 2 and example 3, find a missing length based on the fact that they are similar. So in the first example, I have poorly drawn rectangles A, B, and C. In order to determine if figures are similar, you go ahead and set up a proportion to determine if the side lengths are proportional. Now, I went ahead and in figure A, I'm going to go ahead and say that the length of side A, and I'm going to compare that to the length of, rectangle B. So the length of A, all right, that's my length, that's 6, and the length of B, that's 6. That's a ratio of 1 to 1 or 1. If I were to do the same thing for the width, it would be width of A over width of B. So the width of A is 3. The width of B is 2. These do not match, and therefore A and B are not similar. Okay? So now I'm going to try A and C, and I'm going to use the same method. I'm going to take the length of C, and I'm going to compare that to the length of A. And I can switch that order as long as on the other side of my proportion, I'm saying the width of C over the width of A. If I'm comparing the two proportions, I want to make sure that I'm using the same dimensions in the top of my ratio versus the bottom of my ratio. And so I put length of C on the top, length of A on the bottom, which means width of C is on top and width of A is on the bottom. So the length of C is 12. The length of A is 6. That's a ratio of 2 to 1. The width of C is 6. The width of A is 3. That's a ratio of 2 to 1. Those are similar ratio. They are proportional because they're both 2s. Right? So we can go ahead. You must set up ratios and compare those ratios. You want to make sure that when you're setting up your ratios, you're solving your proportions using equations, which I'm going to show you in the next example. So this is in example 2 and 3. I'm telling you they are similar. Because they are similar, they have corresponding angles that are the exact same, and the corresponding side lengths are proportional. So if I go ahead and say side 6 corresponds with 9, because they're the same location on the different figure, I would say 8 corresponds with X, the missing angle. Now, as you notice, I'm using corresponding sides as the first part of my ratio and corresponding sides as the second part of my ratio. In doing that, I'm making sure I'm saying first one, second one, triangle, first one, second one. I need to be consistent. Now I use cross products. 6 times X equals 72. 6, or I can even do 9 times 8 if I needed to. Divide by 6, X equals 12. So my missing side length is 12, but I had to set up an equation to do so. I'm going to do the same thing in my example 3. In example 3, I'm going to go ahead and say the long length of the first figure over the long length of the second figure is equal to the 9, which is the width of the first, compared to the width of the second. Okay? So I want to make sure I'm clear on this. This is length, length, width, width. This is figure 1 length, figure 1 width. You have to be consistent about how you're setting up your proportion. I am going to require an equation. So x times 5 equals 9 times 8. 5x equals 72. Divide by 5. X is equal to, I think that's 14.4. So, you need to be able to go ahead, understand what the definition of a similar figure is, the two characteristics of a similar figure. You should be able to determine if figures are similar by going ahead and writing proportions and looking and comparing the ratios. You also need to be prepared to find a missing side length, knowing that two figures are similar, and setting up a proportion, writing an equation, and solving. I want to clarify, everything I wrote down, you need to write down. If at any point in time you need to go ahead and hit pause and go back a little bit, please do so. Please use this side, the empty spaces in your green spiral, to write any notes or to go ahead and write notes that you're going to email me. Thanks, guys. Have a good one.